Hello everyone, welcome to Akshara IIT Foundation. This is Srinivas, your maths faculty. Let us go to the today's class. Today we are going to discuss about the topic of probability. So let us discuss some terms based on the probability. First of all, you should have an awareness about the terms. First, random experiment. Random experiment is nothing but a trial. Elementary event or simple event. Okay, na? Elementary event or simple event. Next, less likely events. Less likely events. More likely events. Equally likely events. Okay, mutually exclusive events and exhaustive events. Sure event, impossible event, and complementary events. Okay, na? Right. So let us discuss about then last we are going to discuss about the probability. Okay. So let us discuss about the random experiment. So random experiment is nothing but an experiment. The result we already known, but we cannot say the exact result when we conduct an experiment. That means, so if you repeat any event or any experiment number of times, we know the result before only, but we don't know what will exactly will be the output. For example, when we tossing a coin, so tossing a coin, we know the results. Either the result will be head or tail, but we don't know exactly what will happen when we conducting the experiment. This is called random experiment. Okay, na? So conducting a random experiment is called trial. Okay, na? So for any identical conditions or any situations, the result will be the any identical situations, result will be the same. That means result will not be defined. That means we cannot know the result before. It can happen in any situations. Okay, na? So that means we know already the result, but we don't know what will happen exactly. Right. Now coming to the elementary event or simple event. The result of a random experiment is called elementary event. For example, when we are tossing a coin, the result will be head. Head is called elementary event. Okay, na? Or simple event. So simply, result of any single repetition or result of any experiment. Okay, na? Random experiment. Now less likely events. Let us discuss about the less likely events. This type of events we can discuss through the examples like, for example, getting rain in summer season. Taken as an example of less likely. Okay, na? So getting rain in rainy season can be taken as more likely events. So less likely, more likely. That means there are more chances to happen more likely events. There are less chances to happen are called less likely events. Clear until then? Yeah. Now coming to equally likely events. That means when we conducting an experiment, there must be equal chance of occurrence or equal chance of happening. Such type of events are called equally likely events. For example, when we throw a die, the die is in the shape of cube, right? So each one having one number. So 1, 2, 3, 4, 5, 6 numbers will be there. 6 faces, 6 numbers will be there. The 6 numbers having a equal chance of occurrence. Same way, when we tossing a coin, how many chances for head? The same chances will be applicable to the tail also. So head and tail are also having the equal number of chances. So tossing a coin can be taken as an example for equally likely events. Same way, throwing a die also can be taken as an example for equally likely events. Clear? Equal chance of happening an event or result. Okay, right. Next, mutually exclusive event. So, for example, so when we conducting an experiment or two experiments, there is no connection between the experiments can be taken as mutually exclusive events. That means their intersection will be phi. For example, E1 is an experiment event or E2 is an event. Their intersection result will be phi is called. That means empty settlement. Mutually exclusive events is nothing but their intersection will be empty set. Such type of events is called mutually exclusive events. Then what about exhaustive events? Exhaustive events means when you conducting the events, event 1, event 2, event 3, all of them must be equals to its sample space. So in between we forgot to discuss about the sample space. Yeah, let me write here sample space. The total number of results of an experiment is called sample space. For example, throwing a die, what are the results will come? So 1, 2, 3, 4, 5, 6. That means in any one of the number can be the result of a experiment when we throw a die. So these are all the results of the experiment when we throw a die. So there are total 6 results. So S is called total results of a total results of an random experiment. Yes. So here also when we conducting some different type of experiments, sum of all experiments should be equals to its sample space. Okay, na? That is called exhaustive events. Now, sure event, impossible event or complementary events. Sure event means when we conducting the random experiment or when we conducting any experiment, the result will be always same. Okay, na? For example, throwing a die, I am just asking that getting less than 7. Getting less than 7 when we throw a die. So whenever we throw the die, obviously we will get less than 7 only because we are having only 6 numbers on the die. So whenever you throw the die, always we are getting the same numbers, right? So less than 7 when we throw the die is always happening. Such type of situations that is called sure event or certain event. Sure event or certain event. Next, impossible event. That means an event never happens. An event never happens is called impossible event. Okay, na? Right. That means getting 7 when we throw a die. When we throw the die, we will get highest value 6 only. How can we get the 7? So it will never happen. So the such type of events are called impossible events. Okay, na? So sure event probability when we take in as sure event probability is 1. Impossible event never happens, no, its probability is 0. Next, complementary events. Complementary events. So before the complementary events is nothing but let us discuss about the probability. It is nothing but a game of chances. It is nothing but a game of chances. So all favorable outcomes by total outcomes. So for example, the match will be going on. Cricket match is going on. So obviously we like any one of the team. So we are always trying to win our match. So our favorite one. So favorite chances by total number of chances. What are the total number of chances? Both two teams are having the winning chances. So 2 chances for the winning, but only one person will be win. Only one person will be win. So 1 out of 2. So half chances for both of the teams. 1/2 chance, 50% chances for both of the teams. Okay, na? So simply probability is nothing but favorable outcomes or favorable outcomes by total outcomes. Probability we are representing with the letter P. Probability of an event. P of E means probability of an event equals to number of favorable events by total number of events. So simply P of E is equals to N of E by N of S. N of E by N of S. S means sample space. N of S means number of elements in sample space. Sample space. Okay na? N of E, number of elements of an event or number of chances of an event. Okay na? Now discuss about the complementary events. Complementary events means an event having a chance of happening, an event having a chance, not having a chance of happening, together will be 1. So for example, probability of an event P of E, that means probability of an event happens is taken as P of E. Probability of an event is not happens is taken as P of E bar equals to 1. Then P of E and P of E bar are called complementary events. Okay na? Number of chances to happen an event, same number of chances to not happening the same event, then P of E plus P of E bar equals to 1. Such type of events are called complementary events. So when tossing a coin, how much chances are happening for getting head, same chances are for happening for not getting head, nothing but getting tail. So getting head, not getting head is equals to 1. Am I right? For getting head, how many chances? 1 by 2. Okay, na? Because when we tossing gun, there are 2 chances to happen. First one tail, second one head. Tail or head. There are 2 chances. We want any one of them. Result will be any one of them, either head or tail. So head is having 1 by 2 chances. Head is not having also 1 by 2 chances. So when you add both of them, 1 by 2 plus 1 by 2 is nothing but 1. So this can be taken as an example for complementary events. Okay, na? Right. Now let us discuss some basic concepts. For example, tossing a coin. Let us see the results of a let us just guess the results of an experiment about the coin. So tossing a coin. So tossing coin. Now I am just tossing only one coin. So for one coin, how many chances can be the result? That means the result can be head or tail. Any other chances? No. So tossing a coin, we have 2 chances. How many chances? 2. Now tossing 2 coins. So 2 coins means both coins can be head. Tossing 2 coins together, 1 coin 2 times both are same. Okay na? So 2 times both of them can be head. Both of the coins can show the result as tail. First one head, second one tail, or first one tail, second one head. So total how many chances? 4 chances when 2 coins are tossed. Okay na? Next, coming to when tossing of 3 coins. 3 coins means all 3 coins can be head. Okay? All 3 coins can be tail. All 3 coins can be head. All 3 coins can be tail. First position head, remaining 2 tails. Second position head, remaining 2 tails. Third position head, remaining 2 tails. Same way, that means 1 head, 2 tails. Now 2 heads, 1 tail. First position tail, remaining 2 head. Second position tail, remaining 2 head. Third position is tail. So total here 1, 2, 3, 4, 5, 6, 7, 8. There are total number of elements or results or sample space. Number of elements in sample space is 8 when tossing 3 coins. Number of elements in sample space when tossing 2 coins is 4. 1 coin is 2. So simply for tossing a coin, the total number of elements, a total number of results, we can take it as 2 power n formula. Okay, now tossing a coin, we can use the formula 2 power n, where n is number of coins. So 1 coin, 2 power 1, 2 chances. 2 coins, 2 power 2, 4 chances. 3 coins, 2 cube, 8 chances. Okay, now? So this is the formula for total number of results. A total number of elements in a sample space is nothing but 2 power n. Now same way, let us discuss about the die. So die you know already. There is no complexity here. Okay, cube is not given here actually. Okay, so for example, if you take a cube like this, okay, so there are 6 faces for a cube. So on a top we are taking as a result, so top can be 1, 2, 3, 4, 5, 6. That means when you throwing a die, there are how many chances? 6 chances. When throwing two dice, there are multiple options will be there. Let me take in a tabular manner. Just check that. So 1, 2, 3, 4, 5, 6. These are the results of one die. So 1, 2, 3, 4, 5, 6. These are the results of second one. Okay. Now both dice can show the result. 1, 1. Here 2, 1. So 3, 1, 4, 1. So I am just changing the results of first die, not changing the result of second one. Now here also 1, 2, 2, 2, 3, 2, like that. So how many you'll get? 6 into 6, 36 results will come. So here 6, here 36. Total number of elements, the total number of chances for throwing one die is 6 chances. Here 36. Same way as a coin, we can write the formula as 6 power n, where n is nothing but number of dice. Okay na? Coins 2 power n. If there are 4 coins involving in an experiment, how many number of results will be having? 2 power 4, 16. Very good. There are 16 results or 16 elements as in a sample space. So same way, 3 dice, how many? 6 cube. 6 cube means, very good, 216. Okay. Now coins, a die is completed. Let us go through the playing cards. So you know the playing cards, right? Yeah. Playing cards having some different symbols. Yeah. So this is hearts. I think Ramahim won't be. Okay. So while you're taking the playing cards, there are some different type of symbols will be there. Hearts and diamond, nothing but rhombus. Okay. 2 shapes will be. Now remaining 2 shapes are spades and clubs. Okay. So let me draw this one. Yeah, spades and clubs. Hearts, diamonds, spades and clubs. First 2 are in red color. These 2 symbols will be in black. Okay, na? So while you are observing the playing cards, on this hearts symbol there are 13 cards. First one is A. So instead of number 1, the letter A will be there. Next, number 2, 3, 4, 5, 6, 7, 8, 9, 10. After king, queen, jack. So total 13 playing cards on heart symbol. Same with diamond also, same will be repeated. Spades also same. And clubs, spades and clubs also having the same number of cards. So total 13 plus 13 plus 13 plus 13, 4 13s are 52. Total number of cards are 52. Among them, king, queen, jack, these are called picture cards. These are called picture cards. Okay, no? So let me discuss some problems, then you will understand how we are doing it. For example, so what is the probability? What is the probability of getting number 2? Okay, na? What is the probability of getting number 2? Before that, let me write the formula. Probability of an event is equals to number of favorable outcomes. Number of favorable outcomes by total number of outcomes. Outcomes are nothing but results. Okay, na? Number of favorable outcomes by total outcomes. So I am giving the question is, what is the probability of getting 2? So let us check how many 2's are there. In a heart symbol, there is a 2, 1, 2, diamond 1, spades 1 and clubs 1. There are 4 2's. How many? 4 chances. For getting 2, we are having 4 chances. Any one of them we can get. Out of how many cards? 52 cards. So after cancellation of 4 table, 1 by 13 is the probability of getting 2. Okay, na? So what is the probability of getting red color card? What is the red color cards here? There are 2 red color cards are there. 2 different type of sets. That means diamonds and heart. Diamonds and hearts both are in red color. Diamond how many? 13. Hearts also 13. That means total number of chances. Favorable chances are 26. 13 red color hearts, 13 red color diamonds. So both are red color only. 13 plus 13. Total 26 favorable cards we have out of 52. That is equals to 1 by 2. So while you are observing the values here, 1 by 13, 1 by 2, the results of the probability is always in a proper fraction. That means the probability value is always lies between 0 and 1. The probability of any event is always lies between 0 and 1. Sometimes 0, sometimes 1. When it is 1, when you are considering as a sure event or certain event, the result always 1. Whenever you are taking as impossible event, the result will be 0. In the remaining all situations, the probability value will be always lies between 0 and 1 only. That means 0 0.1, 0 0.6, 0 0.7, whatever, 0 0.9 like that. Between 0 and 1, only 2 situations we are having equals to. So probability of an event is 0 less than or equals to P of E less than or equals to 1. Okay, na? So when the 1 is happening, when it is a sure event. When the 0 is happening, when it is an impossible event. Okay, na? Right. So let us discuss about concept based questions. Yeah. The probability of an impossible event. The first question is the probability of an impossible event is 0. Just now we have discussed. Now question number 2. The second question is given that the probability of getting 2 heads when 5 coins are tossed. So when 5 coins are tossed, 2 heads we need to get. Okay, na? That means out of 5 coins we should get 2 heads, 5C2. Am I right? And the total number of coins. So what? Okay, let us write according to the steps. So for example, probability of an event equals to favorable outcomes n of E by total number of outcomes n of S. Okay. So total number of outcomes means tossing 5 coins together, how many outcomes will come? 2 power 5. 2 power 5 is nothing but 32. Among them, we need to get 2 heads. That means out of 5 coins, we should get 2 heads. So 5C2. So we are using the combinations also here. 5C2 means 5 into 4 by 2 into 1. So 2 table in 4 2 times. 5 2s are 10 by 32. After cancellation in 2 table, 5 by 60. Getting 2 heads while tossing 5 coins together. Then the result will be 5 by 16. Okay, na? Now let us move on to the question number 3. Third question. The question is given that the probability of getting at least 2 heads when tossing a coin 3 times. At least 2 heads when tossing a coin. At least, at most. At least means minimum 2. At most means maximum 2. Okay, na? Right. So the probability of getting at least 2 heads when tossing a coin. So when tossing 3 coins, what are the possibilities? All 3 can be heads. Okay. All 3 can be tails. Head, tail, tail. Tail, head, tail. Tail, tail, head. And tail, head, head. Head, tail, head. And head, head, tail. So these are total 8 results. Here asking the question is at least 2 heads. That means minimum 2 heads are there. Minimum 2 heads we need. Here minimum 2 heads means here 2 heads, 1 tail. Here also 2 heads, 1 tail, 2 heads, 1 tail. There are 3 situations and 3 heads. Minimum 3, at least 2 heads means minimum 2, more than 2 also. So there are 4 possibility chances out of total number of outcomes are 1, 2, 3, 4, 5, 6, 7, 8. 3 coins means 2 cube 8. So 4 by 8. That is nothing but after cancellation we will get 1 by 2. Therefore the probability of getting at least 2 heads when tossing 3 coins is 1 by 2. Okay, no? So let us go through the question number 4. Right. Fourth question, that is given that when a die is rolled, the probability of getting even number. So when a die is rolled, what are the outcomes we are having? 1, 2, 3, 4, 5, 6. These are the possible outcomes. Among them, what are the even numbers? 2, 4, 6. So even numbers are 6. That means how many even numbers we are having? 3 even numbers. Total number of elements are 6. Therefore the required probability is equals to n of e by n of s. Favorable outcomes by total outcomes. So 3 by 6 nothing but 1 by 2. Okay, no? So let us move on to the question number 5. Right. The fifth question, when a card is drawn from a pack, the probability of getting king. So pack we have discussed already about the pack. There are 4 different symbols. In each symbol we are having 13 cards. 13, 13, 13, 13, nothing but total 52 cards. Okay, na? Right. Now here the question is asking about, so what is the probability of getting king? How many kings will be there? So hearts 1 king, diamonds, clubs and spades. There are 4 kings. So 4 out of 52. So the probability is, after cancellation, answer will be 1 by 13. Next question number 6. The probability that a leap year have 53 Sundays. Leap year means how many number of days? 366 days. So we need to find the probability of getting 53 Sundays. So let us get actually for how many Sundays we'll get. We know that for 1 week there are 7 days. So after dividing 7, 7 5s are 35. 1, 6 down, 7 2s are 14. 2 remainder. That means all days we are getting 52 times. Sunday 52 Sundays will come, Monday 52, Tuesday 52, like that. But here the question is 53 Sundays. That means in remaining 2 days, out of 366 days, we got remaining 2 days. Out of these 2 days, we are having any one of them can have a Sunday. So 2 chances for Sunday out of 7, 2 by 7. 2 by 7 will be the probability of getting Sunday. Okay, na? That means these 2 days can be any one of the day, right? Monday, Tuesday, Thursday, Friday. So the chances, the probability we are checking, that is 2 out of 7, 2 by 7. Right. Next, If it is a leap year, how many chances? Sorry, non-leap year means 365, 1 remainder. Then the chance will be 1 by 7. Okay, na? Next, question number 7. Seventh question is given that the bag containing 4 black balls, 6 red balls, 4 black, 6 red color balls. Yeah, total 10 balls. If one of the ball is drawn at random, the probability that is red. So total number of balls are 10 balls. So randomly pick up the ball. That is nothing but without seeing it, can we take a ball? So what is the chance of getting red color? Red color, how many are there? Chances of red color are 6. Therefore, the probability is 6 by 10, 3 by 5. There are the chances is 3 by 5. Okay. Now let us move on to question number 8. Yeah, that is given that the 2 dice are rolled simultaneously. 2 dice. 2 dice means there are 36 chances will be 1, 1, 1, 2 like that. Okay, na? The probability of getting even numbers on both the dice. So for doing this, let me draw the diagram. Okay, so I am taking here 1, 2, 3, 4, 5, 6. I am taking all the possible events. Here also 1, 2, 3, 4, 5, 6. So here chances of 1, 1, 1, 2, 1, 3, 1, 4, 1, 5 and 1, 6. Here 2, 1 like this. So like how many chances we are having? 6 into 6, nothing but 36 chances. Okay, then what is the question here actually? Both can be the even numbers. Both can be even numbers. So let me complete this, then you will understand clearly. Okay, 5, 1, 5, 2, 5, 3, 5, 4, 5, 6, 5, 7. Now here 6, 1, 6, 2. Okay. So these are the possible of outcomes. Okay. Now both must be even numbers. So I am just checking in only even numbers. 2 is an even number. Here 2, 2 even number. 2, 4, 2, 6. So in 2's there are 3 even numbers. Means both the dice shows the even numbers. Now here 4, 4, 2, 4, 4, 4, 6. Next 6, 2, 6, 4, 6, 6. Any other chances? No. So total 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 chances out of 36. After cancellation 9 table 1 by 4. So your result will be 1 by 4. Okay, na? Now here also we can call, we have to discuss about the doublets. What are the doublets? That means both the dice shows the same result are called doublets. Like 1, 1, 2, 2, 3, 3. These are all called doublets. This is 4, 4. Yeah, these are all called doublets. Okay, na? So both dice shows the same result. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. These are called doublets. Remember it. It will be useful. Okay. Now let us start exercise 1 problem. Right. So the first exercise, that is the probability that a leap year contains 53 Mondays and 53 Tuesdays. So leap year means when we doing it, we already did here. There are 2 remaining days will be there. The 2 remaining days, but you are asking the different question is there here. That before question it is given only the 53 Sundays. So for Sunday we are having two chances. But here 53 Mondays and Tuesdays we are having. That means the 2 days can be Sunday and Monday. The remaining 2 days will be there, no? So Sunday, Monday they can, or Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday. The 2 days can be Thursday, Friday, and Friday, Saturday, and Saturday, Sunday also. Okay, na? So how many chances are there? 1, 2, 3, 4, 5, 6, 7 chances. Among them, here are clearly mentioned that 53 Mondays, 53 Tuesdays. So both Monday, Tuesday. Monday, Tuesday, how many times? Monday, Tuesday, only one time. Nothing but 1 out of 7. So 1 by 7 will be our required answer. Let us try to get the second question. The probability of non-leap year will have exactly 52 Mondays. So we know already for leap year or non-leap year we will get exactly every day 52 times. All will come 52. That means when we doing the division like 365 with 7, we get that 52, right? 1 day is remaining. That day can be Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. 7 chances. But here clearly given that we want only 52 Mondays. That means this day cannot be Monday. Okay, na? 53 Mondays, am I right? Yeah, 52 Mondays. So already 52 Mondays we got. So this day cannot be Monday. So this day can be remaining all. Remaining all means remaining how many chances? There are 6 chances. 6 by 7. When the result is 6 by 7, that one day will not be Monday. So it will get exactly 52 Mondays. So the result is 6 by 7. Now let us move on to the problem number 3. That is, when a die is rolled twice, how many will get? There are 36 chances. I draw the table also. Okay. The probability of getting doublets. Doublets, I told you just now, doublets mean the same numbers should be repeated on the face of the dice. So how many are there? 1, 2, 3, 4, 5, 6. There are 6 doublets are there. 6 out of total number of results are 36. Both are cancelled in 6 table. Therefore, the result is 1 by 6. Okay, now. Therefore, the result is 1 by 6. Now, let us go to the problem number 4. Right. 2 cards are drawn at random from a pack of 52 cards. 2 cards are drawn random. 2 cards this time. 52 cards. The probability that one of them is black and one of them is red color. Okay, black color, how many are there actually? 26. Okay, now 13 spades and 13 clubs. So, one should be the black. So, from 26, one should be black and remaining 26, one should be red. So, total 52, 2 cards we should select. From the 52 cards, we are selecting 2 cards. In that, one card will be black and one card will be red. So that is equal to 26 C1 means 26, 26 C1 means 26, by 52 C2 means 52 into 51 by 2 into 1. Okay, na? So when you apply the reciprocal, the 2 into 1 goes to the numerator. 2 into 1 means 2. 26 2s are 56 2, sorry, 26 2s are 52, denominator 52 cancel, the remaining numbers are 26 by 51. So this is the probability of getting one black, one red color card when take 2 cards randomly. 26 by 51. Your option is 2. Now let us move on to the next problem. I think problem number 5. Question number 5. Right. Now in a bag there are 10 balls in which 3 are red color. So 10 balls will be there, among them 3 are red color. So if 2 balls are drawn from the bag, 2 balls are drawn from the bag, then the probability that there will be at least one of the two is red color. So among the two, one should be the red color. Okay. Let us see first how many balls are there, total 10 balls are there. Among them, how many we should take? There are two chances, two balls we have to pick up. 10C2, total number of chances, 10C2. From the red color, 10 balls, 3 are red color. Am I right? Yeah, that means 7 different color and 3 red color. At least one red color we want. Among the two balls, one must be red color. Red color we are taking from 3C1 and second ball 7C1. Okay, now this is one chance, or both can be red color 3C2. Okay, let us try to finish it. So 3C1 is nothing but 3, 7C1 is nothing but 7, 3C2 means 3 into 2 by 2 into 1 divided by 10C2, 10 into 9 by 2 into 1. So 3 7s are 21 plus 2 cancel, 3 by 2 table here 5 times cancel, 5 9s are 45, 45 by 1 means 45 only. So 21 plus 3, 24 by 45. So both are cancelled in, 3 table, 3 8s are and 3 15s are. So 8 by 15 will be the result of the probability. This means this event. Okay, na? Let us move on to the problem number 6. The sixth problem is given. If 2 cards are drawn from well-shuffled pack, 2 cards are drawn from well-shuffled pack. Well-shuffled pack means how many number of cards will be there? There are 52 cards. Okay, 2 cards we need to take, 52 C2. Okay, remember it. The probability that at least one of the 2 is hot. One of the 2 is hot. At least one. So 52 cards, we need to select 2 cards. One should be hearts. Hearts, how many hearts are there? 13. At least one means 13 C1. And in 52, 13 are red color. Remaining how many? 39. From remaining 39, one can come. Or both of them can be hearts. At least, because you are using the sentence at least. That's why minimum one heart symbol card can come, or 2 of them can be coming from the heart symbol card. Okay. Now 13 C1 means 13 into 39 plus 13 C2. 13 C2 means 13 into 12 by 2 into 1 divided by 52 C2. 52 into 51 by 2 into 1. Now 2 table in 12 6 times. In the numerator, I am just taking 13 as a common. Then first term 39 will be remains, and here 6 will be remains, divided by, it is reciprocal. I am using 2 into 52 into 51. So 2 table here 26 times, 13 table here 2 times. Okay, now 13 2s are 26. Now 39 plus 6 is 45. 45 by 2 into 51. Again 3 table having a chance. 3 table here 15 times and 3 table here 17 times. So 15 by 34. Therefore, the probability of this event is 15 by 34. Okay, na? Now, let us go to the 7th question. The 7th question is inappropriate. That means the question is not given completely. There is a mistake in that printing. So, just leave the 7th question. We are going for 8th question. Okay. Now, question number 8. That is, if n coins are tossed simultaneously, n coins, coin means 2 power n formula, n coins means 2 power n only. The probability of getting head an odd number of times. Probability of getting head an odd number of times. So when a coin is tossing, there are number of chances is 2 power n. In the 2 power n, how many number of times head is appearing? So head and tail both are having equal number of chances. That means head can happen 2 power n by 2. That means half of the times head will be happen, half of the times tail will be happen as a chances. Okay, na? Because of 2 chances even of them. Equal chances. Okay. Now the required probability is equals to favorable outcomes 2 power n by 2 and total outcomes is 2 power n. Nothing but by 1 we can write. So try to apply the reciprocal. That is the chance is half. Okay, na? 1 by 2 is our required answer. Let us move on to the question number 9. That is given that a single letter is selected from the random of the word probability. Now we are taking the word probability. Yeah. So the probability that is a vowel. So how many lettered word it is? So 3 plus 3, 6 plus 3, 9, 10, 11. There are total 11 letters. Among them vowels. How many vowels are there? So O is a vowel, A is a vowel, I 2 times. So there are 4 vowels. Okay, na? Yeah, 4 vowels remaining are consonants. So total 11, so remaining is 7. Here 4 and 7. Therefore the probability of getting vowel is 4 out of 11. Number of favorable outcomes 4. Total letters are 11. 4 by 11 is our required answer. So let us move on to the question number 10. The probability that in a family of 4 children, there will be at least one boy. So 4 children, there will be at least one boy. Out of 4, only one boy can have a chance. And 2 boys have a chance. 3 boys, all are boys. 4C3, 4C4. Okay, and 4 chances, no? Total number of possibilities. These are the required chances, number of n of e. Okay, no? Now n of s, what is the n of s? Total number of chances, each one having 2 chances. That means each kid have a gender of either boy or girl, 2. Each one 2 chances, like 4 people. Like a same coin, like 4 coins means 2 power 4. Same way, 4 children, 2 power 4. 2 power 4 is nothing but 16. Now let us try to find it. The probability is P of E is equals to N of E by N of S. Okay, na? That is equal to 4C1 means 4. 4C2, 4 into 3 by 2 into 1. 4C3, 4C1 same. 4C4 means 1 divided by 16. So here 2 table 2 times cancel. 4, 2, 3 are 6. 4 plus 6, 10. 10 plus 5, 15. 15 by 16. Because it is asking the question like at least. 15 by 16 our result. So question number, sorry, option 4. Now problem number 10. Yeah, 10th question is given that the probability that in a family of 4, 11th question, 10th one already completed. Now 11th one. That is 7 persons sit in a row at random. 7 persons sit in a row at random. The probability that 3 persons A, B, C is sit together in a particular order. Okay, na? So 3 persons sit together in a particular order. So let us take 7 members. So 1, 2, 3, 4, 5, 6, 7. Okay, na? So 3 persons sit together. Together means these 3 can be taken as 1 unit. And remaining 1, 2, 3, 4. 4 units. Nothing but 5. So 5 factorial. They can arranging in a 5 factorial. And total, how they are arranging 7 members? 7 members we can arranging in 7 factorial. So 5 factorial by 7 factorial ways. That is our required answer. Let us move on to the question number 12. So one number is selected at random from the 4-digit number, can be formed from the digits 1, 2, 4, 5, 6, 7. 1, 2, 4, 5, 6, 7. So these are the digits. Then the probability that it is an odd number is, yeah, actually here 3 also should be given, 3 is missing. In the question 3 also must be given, 3 is missing. Okay, na? So one number is selected at random from the 4-digit number. 4-digit number 1, 2, 3, 4. 4-digit number 1 should be taken. That can be formed with the digits 1, 2, 3, 4, 5, 6, 7. That means 7. then the probability that it is an odd number. So probability of an odd number. So how we are total number of arrangements n of s. So first one we can arranging in 7 ways because of 7 numbers. So 7, 1 is already used. So 6 having chances. Second is 6 chances. This is 5 chances and it is 4 chances. So 7 into 6 into 5 into 4 we are arranging in these many ways. Okay na? Right. Nothing but 7C4 or 7P4 we can write. So same answer will come. So 7 into 6 into 5 into 4 total number of chances. But here asking that how many chances can be the odd numbers. In this how many odd numbers are there? 1, 3, 5, 7. There are 4 odd numbers. That means the last position, this last digit can be arranging in 4 different ways. 4C1. 4 different ways are 4 chances. And remaining 3 chances we can arranging in any like. That means these 3 chances can be taken by the remaining digits, nothing but 6C1. Sorry, 6P3. Okay na? So the last digit is 4C1, then only will be odd number. So 4C1 into 6P3 by this. So required probability P of E is equals to 4C1 into 6P3 by 7 into 6 into 5 into 4. 4C1 is nothing but 4. 6P3 means 6 into 5 into 3 by 7 into 6 into 5 into 4. 654. 654 cancel. 3 by 7 is our required probability. 3 by 7 is our required probability. Okay now? But option is not given. Have we cancelled properly? 6 P3 means 6 into, yeah, sorry, here 4 will be. 6 P3 means 6 into 5 into 4. Sorry, 4 will be here. So 4 by 7. Now we are getting the answer. Okay. Now let us move on to the next problem. Problem number 13. Yeah, that is given that a card is drawn at the random from the pack of 100 cards. 100 cards numbered from 1 to 100. There are 100 cards will be there. There are 1, 2, 3, 4, 5 like that numbering on the cards. Okay, probability of drawing the card which is numbered a perfect square. So 1 to 100, how many perfect square? Total 100 cards are there, n of s. And n of e, how many perfect square? Perfect squares means square number. 1 square 1, 4. That means square number just write 1, 4, 9, 16. 4 square 16, 5 square 25, 36, 49, 64, 81. So total 9 square numbers. 100 square is 110. So 1 to 100 there are 10 square numbers. 10 by 100 nothing but 1 by 10. The probability of getting square number card from pack of 100 cards is nothing but 1 by 10. Let us move on to the question number 14. The 14th one, a bag contains 50 tickets numbered 1 to 50, same like the cards only. So which are 5 are drawn at random. So among the 50 cards we need to draw 5 cards and arranged in ascending order of magnitude. Ascending order also is given: x1 less than, x1 less than, x2 less than, x3 less than, x4 less than, x5. So this is the order. That means they must be arranged in ascending order, small to big order. So 5 cards we have to select it. Then the probability of x3 is 30. Probability of x3 is 30. So x3 value should be 30. That means x1, x2 having 29 chances, 1 to 29, because we are writing in ascending order, right? So x1, x2 can be happening of 29. That means in 29 numbers, x1, x2 can be any one of the number. x3 can be 30 it seems. And x4, x5 also 31 to 50. Here 1 to 29 chances for x1 and x2, 31 to 50 chances for x4 and x5. Okay na? So let us try to Write its probability of an event. How many chords we have to select? 5 chords out of 50. 50 C5 and 1 can be 30. 30 having x3 can be 30. Only one have one chance, 1 C1. And x1, x2 having 29 chances. So 29 C2. x1, x2, 2 chances. 2 chords having 29 chances. The remaining 2 chords having 20 chances. 31 to 50, 20 chances. 20 C2. So this can be our required answer. That is nothing but option number 3. Because 1 C1 value is 1 only. So 29 C2 into 20 C2 by 50 C5 we can write. Because 1 C1 value is 1 itself. Okay, na? Let us move on to the question number 15. Right. So a bag contains 4 red color, 3 black color, 2 white color balls. If 3 balls are selected, total how many balls? 4, 3, 2. So nothing but 9 balls are there. From the 9, 4, 3, 2, 4 red color, 3 black and 2 white. Total 9 balls. Okay. We need to choose 3 balls. 3 balls we have to select it at random. The probability of selecting at least 1 is white. So 3 selection, total number of selections NC3. Now the question is probability of selecting at least 1 white ball. 1 white ball means, yeah, white here there are 2 white balls. So 2C1 and remaining total 3 balls no. So 1 ball we are picking from 2 white balls, remaining 7C2. And both can be white ball and 7C1. That's it. Highest value is 2 only for the white balls. So 2C1 value, 2C1 value is 2 and 7C2 value 7 into 6 by 2 into 1. Plus 2C2 value is 1 and 7C1 value is 7 by 9C3. 9 into 8 into 7 by 3 into 2 into 1. After cancellation, 7 6 are 42 plus 7 49. So numerator is 49 by denominator 3 table here 3 times, 2 table here 4 times, 3 4s are 12, 12 7s are 84. So 49 by 84. Both can be cancelled in 7 table again. 7 7s are 7 12s are 7 by 12 is our required answer. That's it. So let us move on to the question number 16. Okay, na? Yeah, the 16th one is given. The 2 boys are asked to select each one of the number from 1 to 100. There are 1 to 100 numbers. So 2 boys are asked to select each one number. Okay. The probability that they select different numbers. So for selecting of different numbers, total how many numbers are there? 1 to 100, that is nothing but 100 numbers are there. That means first person is selecting. Chances of first person of selecting a number, 100 chances. For first person, there are 100 chance. Second person also will have 100 chance if they can pick up same numbers. But they should pick up different numbers. That means first person is having already 100 chances. From that 100 chances, he has taken only one chord already. So remaining 99. Among the 99 chords, he has to pick up one. So the second person chances is 99. Second person chances is 99. So the probability is 100 into 99 by 100 C2. From the 100, we have to take 2 numbers. We have to select 2 numbers. 100 C2 out of 100 into 99. Now let us move on to the question number 17. Yeah, this question is given that if x is an integer, x belongs to 1, 5. X is an integer, x belongs to 1 to 5. That means whenever it is given that 1 to 5 in a closed bracket, x having a chances of 1, 2, 3, 4, 5. That means 1 to 5. Am I right? Yeah. Therefore, the probability that x square minus 3x plus 2 greater than 0. x square minus 3x plus 2 greater than 0. We can do it in two different manners. You can find the factorization for this also. So let me try to find the factor. 2 factors, 2 ones are 2. So that you can write it as 2x and 1x. So x common, x minus 2. Here minus 1 common, x minus 2. So x minus 2, x minus 1. That means x value can be 2. If x value 2, 2 minus 2, 0, it cannot be greater than 0. Or if x value 1, 1 minus 1, 0, it is also cannot be greater than 0. So x cannot be 1 and 2. It cannot be 1 and 2. So still how many chances for getting x more than 0? 3 chances. 3 out of 5. 3 by 5 is the probability. Let us move on to the question number 18. Yeah, 1 second. Right. So entries of a 2 by 2 matrices. 2 by 2 matrices are chosen from the set of 0, 1. So 2 by 2 matrix. So you will get in intermediate like this. Matrix will be here. 2 by 2 matrix means 1, 0, 0, 1. Like this 2 by 2 matrices will be there from the set of 0, 1. That means it should have the elements only 0, 0 and 1. And the probability that the determinant has value 0. Determinant having the value 0. Determinant means if you take a 2 by 2 matrix like this, A, B, C, D, the determinant will be AD minus BC. That means AD into BC value should be 0, it seems. Like that, how many chances will be there? Okay, now, so let me try to write the possibility chances. So I am taking 1 here, 1, 0. Yeah. Okay, na? 0, 1. Okay, na? Now 1 in the first position, 1 in the second position, 1 in the third position. Like this 4 chances. So same way 1, 1 also here. Cross also we can take. Sorry. 1, 0, 0, 1 we can take. So AD minus BC, 1 into 0, 0, 1 into 0, 0. This is also one of the chance. This is also one of the chance. Okay, na? All ones also can be the chance. 1 ones are 1, 1 ones are 1, 1 minus 1, 0. All zeros also can have the chance. Okay, na? So total there are 8 chances. Total number of chances are 8. The probability that the determinant have the value 0. 0 having the 5 chances among them. So we can arrange them into 5 by 8 ways. Total number of chances we can arrange them into 5 by 8. Okay, let us move on to the next problem. So problem number 19, while shuffling a 52 playing cards. Shuffling 52 playing cards. Yeah, 2 are accidentally dropped. So 2 cards already dropped, still 50 cards will be there. The probability of the 2 missing cards to be different colors. So different colors means total 2 colors will be there. One is red color and one is black color. The color may be taken as red or black. Okay, red and black. So let me try to write it here. So total chances is 50 to C2. Among them, 2 cards are dropped. One can be red, one can be black. Same answer. So 26 into 26 by 52 into 15 by 2 into 1. 26 by 51 chances. Okay. So question number 20. That is, a box contains 5 white socks. A box contains 5 white socks and 5 blue socks, well mixed. So a man picks socks at random. The probability of both socks to be matched. So out of 10 he has to take 2 socks as probability of both match. From the out of 5, 2 has to selected. That means 5 black color, yeah, 5 white and 5 blue. Both should be blue or both should be, yeah, both should be blue or both should be black. Or means plus. So 5C2 means 5 into 4 by 2 into 1. Here also 5 into 4 by 2 into 1. So 10C2 means 10 into 9 by 2 into 1. Now here 2 times, here also 2 times, 10 plus 10 numerator will be 20. Now here 5 times, 5 into 9, 5 table here 4 times cancel, 4 by 9 is the probability. Okay, na? Let us move on to the problem number 21. Yeah, question number 21 is given that if A comma B are disjoint sets and K is, yes, here also it is not given clearly. If A and B, we know clearly what are the elements in the A and B, we can identify the value of K, but it is inappropriate question, we can neglect this. So question number 22, 6 faces of die are mixed with the numbers. So actually die is having numbers 1 to 6, but here numbers are given that 1, -1, 0, -2, 2 and 3. These are the numbers are on the faces of the die are thrown thrice, 3 times. 3 times means 216 chances will come. Okay, the probability that the sum of the 3 numbers thrown is 6. Probability is A by B cube. Already given, the given probability is A by B cube it seems. So we need to find out the value of A minus B. We need to find A minus B value. Okay, no? So but here asking that sum of the 3 numbers is 6. Sum of the 3 numbers means if you take that 3 times, sorry, 3 2 times, 3 plus 3, 6, 6 plus 0. So the chances is 3 comma 3 comma 0. This is the chance. First chance. Next 3 0 3 0 3 3. Okay, 3 completed. Next 2. 2 and 1 if you take that another one cannot be chance because 2 plus 1 3 and another one is also 3. Am I right? 1 2 3. Yeah, 1 2 3 we can take. So 1 2 3 we can take. 1 3 2 we can take. Next 1 completed. Now with 2. With 2 2 1 3 2 3 1. With 3 3 1 2 3 2 1. Any other chances? No. So total there are 9 chances here. 3 3 3. There are 9 chances. So the probability is 9 by total number of outcomes. While tossing 3 throwing 3 dice is 6 cube, nothing but 2 power 6, sorry, 216. So 9 by 213, that is equals to, it is equals to A by B power 3 it seems. So 9 by 213 can be expressed as 6 cube. So when we compare A value is 9, B value is 6. So we need to find A minus B. A minus B nothing but 9 minus 6 is 3. Our required answer is 3. Okay, now? Now let us move on to the next problem. Problem number 22. Right. So 10 boys are arranged at a random along a circle. When you are having the circular way arrangement n minus 1 factor, you should remember the formula. Okay. The probability of the arranging them so that 2 specific boys of those of them must come together is k by L, then the value of k minus L. Okay. For arranging 10 boys in a vase is nothing but 9 minus 1. So 10 minus 1, 9 factorial ways. Arranging all 10 boys in a circular way. Then after 2 boys together. So among the 10 boys, if you take 2 boys, still 8 boys will be there. So 8 boys we can arranging them 8 factorial into 2 factorial. Okay. Yeah. Now 2 boys come together, that means remaining 8 boys, and 2 boys are arranging in 2 different ways. 8 into 2. This is n of e. This is n of s. Therefore, the probability is equals to n of e by n of s. That is equals to 8 factorial into 2 factorial by 9 factorial. 9 factorial we can write it as 2 factorial value 2. 9 into 8 factorial. 8 factorial cancel 2 by 9. Therefore, the probability is 2 by 9. It is nothing but k by L, it seems. K by L. So, k value 2, L value 9. So, modulus of k minus L. That means modulus of 2 minus 9, nothing but minus 7. Whenever it is modulus, minus becomes plus. So, answer is 7. Let us move on to the question number 24. Alright? Yeah, 24. That is given that 3 numbers are chosen at random from the first 20 natural numbers. So, from the first 20 natural numbers, 3 numbers choosing randomly. So, 20 C3 selection. Okay. Then the probability of that their product is odd number is 1 minus PC3 by QC3. It is given that 1 minus PC3 by QC3 it seems. Okay. Then find the value of Q by P. Right. So, first 20 natural numbers, then the probability of their product is odd. So, that is 10C3. Let us take the 10C3 by 2C3. Okay, na? Yeah, just one moment, children. Yeah, 3 numbers are chosen at random. So, we are selecting 20 natural numbers, 20 C3. From the 20 C3, the probability that their product is odd number. Product must be odd number is 1 minus PC3 by QC3. So, we need to here we can use the complementary event. What is the complementary event? We can write P of E is equals to 1 minus P of E bar. I told you already P of E plus P of E bar is equals to 1 now. So based on this, that is equal to 1 minus 10C3 by 20C3. So 20 minus 10. Am I right? We need to find the value of Q by P. Q by P. So here just compare here like this, 20 and 10. Q by P is equals to 20 by 10, nothing but 2. Because both the product of 20 natural numbers means, so product of odd numbers and probability that their product is odd. Product can be odd number and product can be even number. 2 chances will be there, no? Yeah, because natural numbers are set of odd and even continuously like that. Okay, let us go to the question number 25. The 5-digit number are formed with the digits 0, 1, 2, 3, 4. Question number 25. The 5 digits 0, 1, 2, 3, 4. There are 5 digits are being here. So without repetition, the probability of getting 2 in tens place and 0 in ones place. The probability of getting 2 in tens place and 0 in ones place. We are arranging the 4-digit number. 5-digit number. First one having only 4 chances, because 0 cannot be in the first place, and remaining we can write it in 4 factorial. So 4 into 4 factorial ways we can arrange them. Next, the probability of 2 in tens position. The tens position can be and 0 in ones position is 1 by a power b it seems. So a plus b value we need to find. So let us find out that 2 in tens position. 2 in tens position we are having only one way, 1C1 we can write. And 0 in which position? 0 in its position. Only 1 0 we are having, that is also we can arranging in one ways. And remaining 3 digits we can arranging in 3 different ways. 3C1. right? Sorry, 3 factorial ways, 3 into 2 into 1, not repetition now. This is P of E value, then, sorry, N of E value. Therefore, the probability is 3 factorial into 1C1 into 1C1 by 4 into 4 factorial. 3 factorial value 3 into 2, 1 value is 1, 4 into 4 value, 4 into 3 factorial we can write, 3 factorial will be cancelled. So 1 by 16. 1 by 16, this is in the form of 1 by a power b it seems, am I right? 1 by a power b or 1 by b power e, yeah, 1 by a power b it seems. That means 1 by 16 I am writing as 2 power 4. 2 power 4 value is 16, or 4 square also we can write it. Whatever, 4 square or 2 power 4 both are same. Therefore, a plus b value, so 2 plus 4 is nothing but 6. The value is 6. Okay, now? Right. So that's it for today, children. Thank you, one and all. Have a nice day. Bye bye.